Jump on with the kids. Oh. All right, we have an inverted cone. Being filled with water at a rate of 10 cubic feet per minute. The tank measures 24 feet tall, has a base diameter of 20 feet. At what rate is the height of the water increasing when the diameter of the water is 12? So, water, and the current height of the water is 12. No, the current diameter of the water is 12. So you've now had a nice kind of introduction to related rates. You can solve the easy problems. Congratulations. Can we solve the more challenging problems? So tell me where to set up. This is the only problem we want to do today. Okay, so V prime is 10. All right. Formula for volume of a cone. 1/3 pi r squared h is the volume of a cone. Diameter of the water. So the radius of the water is 6. Radius of the water is 6. What do I want to find out? H prime, the rate at which the height is increasing. Now, what's really important to notice here is this distinction, okay? We really have kind of two cones. We have the larger cone, and then we have the cone shape that the water is producing, right? So look at this. You have the original shape. Does the 24 ever change? No. Does the 20 ever change? No, it doesn't. But does this diameter of the water, the 12, does that change? Yeah, so we do have a lot of changing parts still. But notice the difference between the diameter of the water and the height of the water compared to the diameter of the cone and the height of the cone. So you'll see why some of it's important, but some of it's not. We can't, for example, some people say, well, the heights never change. It's always 24, so plug the height in. You're right. The cone height is never changing, but we're not wondering about the height of the cone. We're wondering about the height of the water. Big difference there. So right now, if I were to take this derivative, true or false, I'd come up with an R prime. I'd also come up with an H prime. Why? Because I would use what rule? The product rule. And you come up with an R prime and an H prime. I have no way of figuring out R prime. So I have to get rid of R. How do I get rid of R? This will always change shape. It'll be proportional. We'll have similar triangles. As you notice here, what is the current radius of the cone? Current radius of the cone is 10. Current height of the cone. So therefore, R is equal to 10 over 24h, or R is equal to, those are both divisible by 2, 5 over 12h. The radius will always be 5/12ths of the height. I can take that and plug that in for R. So now I have volume is 1/3 pi times 25 over 144 h cubed. Somebody, 3 times 144. So I have to take the h and square it to get h squared times another h to get h cubed. Because that radius is changing. That's the radius of the water. As it fills up, that radius will change. So I can't plug it in right now. So I think we have 25 pi. Can somebody confirm on their calculator? I think 3 times 144 is 432. Okay, thank you. Great. I now have a formula for volume in terms of just H as opposed to H and R. Derivative with respect to what? Time of volume equals 25 pi over 432 H cubed. So V prime is 75 pi over 432 H squared H prime. We good? What is V prime? 10 equals 75 pi time over 432 times H squared. Do you have the current height? No. This is why we're going down this road, so you can understand why is the height not 24. Yeah, the height is referring to the height of the water, not the height of the cone. Can we figure out the height of the water? We have a relationship right here. R over H is 10 over 24. Do you know the current radius of the water? What is the current radius? So 6 times 24 divided by 10, right? 6 times 24, 144. Divided by 10, 14.4. Squared? $207.36. I now have enough information to solve. Take out my handy dandy calculator. Can't do any of this in my brain. We're going to take 10. I'll divide it by 75. I'll divide it by pi. I'll multiply by 432. I'll divide by 207.36. 0.088. 0.088 what? Feet per minute. Since height is a linear measurement, it's just a one-dimensional measurement. I don't have feet squared, I don't have feet cubed, just have feet per minute. And that's it. A bit of a challenging problem. But now what you are able to do is this. You have the rest of the time to work, but I want you to know level 1, you should be doing 1, 2, 3, 4, 5, 6. Level 2, you should be able to do 7, 8, 9, 10, 11, and 12. And then on the back side here, you should be able to choose for sure 4. I encourage you to look at this one, this one, this one, maybe this one, but yeah, this is a good one to try. The rest of the time is yours. Let's go.